So hello everyone, hope you're doing good. And today is day 29th of the daily Leetcode challenge. And today we have a hard question with us. It's question 1402, reducing dishes. So let me quickly explain you in brief what this question is. So this question tells about a chef who will be cooking and dishes, and then the dishes can be cooked in any order, right? And it did not be cooked also. Like you can eliminate some of the dishes from cooking. So ultimately, what he's saying is we have to calculate a value named lifetime coefficient, and we have to choose a dishes such that we can maximize the lifetime coefficient. So what it means, let us see in detail now. So a chef has collected data on satisfaction level of his end dishes. Chef can cook any dish in 1 minute of time, right? So all the dishes are going to take 1 minute of time. Lifetime coefficient of a dish is defined as the time taken to cook that dish, including previous dishes. So what that means is, suppose I'm in dish zero, I need to count the time for cooking the previous dishes as well. For example, for minus one and minus eight, I will cook them in one time and two time, right? It will take one plus one time, and while I come to the third dish, it will take one plus one, which is 3 units of time. So the 3 units of time I need to multiply with satisfaction of I. Okay, I satisfaction I means a member in this array. So this is the satisfaction array. But when it comes to time, I have to take the cumulative time. Okay, to for example, I'm in the third dish, that means it will take 3 units of time. This time of I will be 3 units into that satisfaction of I, which will come from this array, right? So this is the important one. The lifetime coefficient of a dish is defined as the time taken to cook the dish, including previous dishes, multiplied by a satisfaction level. So please keep that point in mind. You have to include the previous dishes time as well. Okay, return the maximum sum of all lag time coefficients about that the chef can obtain from after dishes preparation. Dishes can be prepared in any order, and the chef can discard some dishes to get the maximum value. So these two things you have to always keep in mind. Any number of dishes can be discarded, and the remaining dishes can be cooked in any order. Okay. For example, now let us take the case of the first example. Okay. So if I sort it out, how it will look. Here I have discussed. Okay, if you sort it like just imagine in yourself, first minus 9 will come, minus 8 will come, minus 1 will come, then 0 and then 5. Okay, so they are trying to take, after removing the second and last dish, which is minus 8 and minus 9, they are trying to take this answer. We will try to see how this can be achieved using programming. And but see, this is a hard level question. Here, brute force solutions are not appreciated, but in interview, if you face such a question, always code a brute force solution. The hard solution you may or may not be able to reach. So what my session will be, always code a brute force solution, and that you should try to optimize, right? So let us see in this question how we are trying to do it. See, the optimized approach which I am going to take is greedy approach with the suffix sum and sorting. But before that, I would like to show you my brute force approach. So yeah, this is my brute force approach. See, the idea here is very simple. We have to sort the array. Once we sort the array, there will be initially some negative numbers, then a zero, and some positive numbers, right? Zero may not be present. So what it will be, initially it will be some negative numbers and then some positive numbers. So from that the part which divides the negative and positive numbers, that index I am trying to store it in my positive number starting index. This variable will show that. So okay. So whenever this condition is true, whenever that I am getting zero or a positive value, I will show that as my positive index starting index. So it will be the first positive number after the negative numbers. That index will be stored in this variable. Why I'm doing it, I will quickly tell you. See, whenever see negative numbers, we may or may not take them, but positive numbers we will always take them, right? See, we'll have to, and we will ensure that positive numbers are always on the right side of the array, so that they are multiplied with their larger indexes. Okay, and we will always ensure that the negative ones are in the left side of the array, so that we get smaller indexes for them. That may or may not be selected, right? See, the question clearly mentions any number of dishes can be discarded, right? See, just try to understand this how they are doing it. In this example, what they did is they took minus one as the first index, then they are taking zero as the second index, and then five, and then yeah, till five only, minus one, zero, and five only, right? So see, ultimately how you are doing it. If you solve this array, you will get that minus one, zero, and five are the rightmost part of the array, right? So whether to take which minus negative values we should take or which one we should ignore, that only we need to see, right? So in the brute force solution, what we are trying to do is, if it's a positive solution, I will definitely take it. If it's a positive value, I will definitely take it, and I will try to ensure it's in the rightmost part of the array after sorting. That means that is what is the meaning of sorting, right? The maximum highest value, positive value, will be in the rightmost part, and for the negative part, we will either take it or we will discard it. That's what we are doing here. So just understand that starting index is the first positive index. That means for the value, it's the index of the first positive number after sorting the array. I'm now declaring a function. Here I'm passing the ith value. That means the ith element which I'm currently considering, the index of it. See, index is different from I here because we may not be considering some of the indexes, right? Suppose I'm discarding it. That means the index will remain the same, right? And the previous sum. So what I'm doing is, if the value, okay, if the value is greater than n, then simply take the answer, maximum of the answers, or all the answers which you're getting. See, here comes the trick part. Okay, if the number is a negative number, that means, yeah, if it's in the left side of the this particular index, pos number starting index, then we may think of skipping it. This is how I am skipping it. See, I am incrementing I plus 1, index is same, index I'm not incrementing, and the sum also I'm not incrementing. But in case of positive numbers, we'll always take them. How we are doing it? See, I am taking next number, I'm going to next number, I'm incrementing the index also, and previous sum also I'm appending it with this coefficient value as of I into index, right? Previous sum plus s of I into index. Index is like the cumulative time to prepare that array, right? See, 1, 2, and 3. Suppose the third index means it will be 3, right? That's how I'm doing it. I'm see, index in this case students are starting from 1. This is the only point you have to consider. I will give the solution in the comments also. You can just explore how it's happening. This is, see, in an interview, if you are preparing, these things are very important. You should not jump to the optimal solution, right? Now coming to the optimal solution, this is the approach I'm going to use: greedy approach plus suffix sum plus sorting. See, there is one thing about Leetcode, that sometimes it will not accept your solution even if it is optimized. It will try to accept only the solution which it feels is optimized one, right? In this case, this is that kind of solution. I will just explain you how it works, right? It's depends on the suffix sum. Suffix means what? The ending part of the array. See, there are two things: prefix and suffix. Suffix means the ending part of the array. We'll be using the sorting as well, and there we use a greedy approach. What is greedy in this? I will explain you. See, these questions are important for. See, this what is greedy? What is the approach? See, in this question of how you're using the greedy approach, these questions you will definitely face in interview, right? So, for example, this is my array, right? A, B, C, and D. Assume that it is sorted. Please don't respond. Assume that it is sorted. So, sorting is done from here, right? Next comes the suffix sum. How I'm taking suffix sum? I will have two variables. One is the suffix sum variable. One is the answer variable. Initially, both will be initialized with 0. Suppose I am starting from right. Okay. Why should I start from right? That is what is the greedy approach. Greedy means you have to think that this solution is going to, this approach is going to give me the final answer, and I will be proceeding with that. So this assumption is coming from greedy approach. I am starting from right to left, right? Initially, both are 0. Then the first value comes is D, right? Add the D to the answer. Now, next value comes is C. C will be added to the D. Okay, it becomes D plus C. But this together should be added to the previous answer. That means D is the existing answer. Add the suffix value now to it. D plus C will be added to it. Okay, what it becomes 2D plus C. Okay. Next we come to B. B add to the other previously C numbers, which is D plus C plus B. But this together will be added again to the 2D plus C. That's what we are doing here, right? 2D plus C plus D plus C plus B. See, this is what is prefix sum, right? It becomes 3D plus 2C plus B. Now we have these values. I am adding A to it. What it becomes? A plus B plus C plus D, right? These value together I am going to add on this value. So what it becomes? 4D plus 3C. See, this is the value, right? A has index 1, B has index 2, C has index 3, and D has index 4. That's what the question is asking us, right? If you see the question once again, see, that is what they're doing. Minus 1 into 1, 0 into 2, 5 into 3, right? This is what they're doing. And now I will show you how to solve example 1 with this. So this is the example 1 given to us, right? After sorting, it will look something like this. Okay. Now see, if you have tried to understand what this is doing, whenever I'm calculating this value ultimately will be added to my answer. See, this was my prefix sum till now, this was my answer till now. This value will now be added to my answer again. Suppose this value is positive, means I should add it. Suppose this value is negative, means it will is reducing my answer. Suppose I'm in my maximum answer. If I'm taking another value which is negative here, it will reduce my answer because it's negative. So we'll see that here. See, initializing both of them with 0. See, this is a suffix sum, this is the answer variable, right? I'm initializing both of them with 0. First value from the right is 5. Why I'm doing from the right? See, first of all, I've used sorting. Okay, sorting is done. Next, I'm going to do suffix sum now, which I will show you. Next is greedy approach. What is greedy approach? Greedy approach is, here we are starting from the positive to the negative numbers. That is from right to left after sorting, which is this order, say this way. First, we'll explore 5, 0, -1, -8, -9. This is the greedy approach. our approach here is we should start from the positive numbers towards the negative numbers, because always positive numbers will be included in the solution. See, first value coming is 5. I'm initializing, adding it with the previous answer variable, which is 0 plus 5, which is 5. Okay. Next comes, see here, always here all the prefixes will be added, right, one by one. See, next comes 0. Okay. 0 I'm adding to the 5. It becomes 5. This becomes 5, right? 5 I'm adding to the previous answer, which is 5 plus 5, 10, right? Now comes minus 1. I have 5, I have 0, then I'm adding minus 1 to it. See, these three. So it becomes 4. 4 is a positive value, right? So I am adding 4 to the previous answer, which is becomes 14. Now comes minus 8. I have these values now, 5, 0, minus 1, and minus 8. Together they becomes minus 4. It's a negative value. If I add a negative value to my minus 14, this answer will reduce. And remember one thing, once the negative value starts coming, it will become even more negative in the next attempt. If you sum all these things, it will come minus 4 plus minus 9, which is minus 13. If you add minus 13 to my this value, what will happen? See see only see till now you must be understanding whatever comes in this value, na, this upper arrow, this upper row, whatever comes, that we are adding to our below row. If I add a negative value to my row, what will happen to my value? It will definitely reduce. So the answer is, whenever the suffix sum comes negative, we should stop adding it. So we should stop here and we should return the answer, which is 14 in this case. Because see, from minus side itself, the suffix value sum is coming as negative, right? Minus 4. If you take minus 9, it will come even bigger negative value. So ultimately, the thing is, it will going to reduce my answer. So I have to stop there. Okay, that is the approach here. And if we come to the solution part of it, see, I'm initially sorting the satisfaction array and is the length of it. See, these are the two variables which I'm going to use. Answer equal to 0, suffix sum from left. Sorry, it should be the suffix sum from right, right? It should be the suffix sum from right, which is 0. For I in range, I'm starting from the rightmost part, okay, which is n minus 1th index. It will go till 0th index and in a reverse way, which is minus 1, right? Whenever I'm writing minus 1, that means it will stop till the next value, which is 0. It will stop. It will just look for turn from minus 1 to 0. So what I'm doing, I'm adding suffix sum from left plus satisfaction of I. Okay, this is what we are doing here, right? The suffix sum from left, which is the existing value. Sorry, yeah, existing value plus the current index, current value in that index. Okay, if that value is greater than 0, see here we short because here we got a negative value, right? So we should always check if this value is greater than 0, then add that value to the sum suffix sum from right. Okay, and add that value, and finally that value should be added to the answer, and we are returning the answer. So you might be knowing how it works now. See, we are only going to take we are starting from right because it's a positive value. Once we come to negative value, we need to be very careful. We will see if my suffix sum is coming positive. If this comes positive, it will contribute to my answer, right? It will make my answer larger. That's why I should add it. If it becomes negative, that means it's going to reduce my answer. That means stop. Now coming to time and space complexity. See, ultimately we are sorting, right? So sorting takes n log n, in even in the worst case in all programming languages. So the time complexity definitely, see, this is n complexity, and here we are going for O of n. Like you will see the bigger one, which is n log n in the sorting, and O of n in the so, like going through that array. So the bigger of them is n log n. That's why the time complexity of the solution is n log n. And coming to space complexity, see, ultimately we are not using any array or anything here, right? We are using only two variables and a number n to store the length. But in the solution, it is mentioned that the sorting will take some space complexity, that is log n. So the space complexity in this case will be log n because we are using the sorting. In if you are in an interview, these points may not matter because these things are nowhere mentioned how it is internally implemented, right? So you may not say, you can say it's O of 1, but if they specifically ask if we to consider the sorting path, then you can say that the space complexity is also log n and the time complexity is n log n. So yeah, friends, that is all for today. If you like the video, please like and subscribe. Thanks a lot.